students. This is KG Misra, and I'm here with the next part of the video lecture. Okay, that for class 9th, and that is on chapter force and laws of motion. Okay, I think in the last video we are solving the Ncert exercise of class of this chapter. Okay, and we have done till question number 15. So here I'm present with question number 16. Okay, in this video we will be finishing the exercise of this, which will be very helpful to you to solve this. Okay, so take care of yourself, okay, and your family also, and keep on studying for a better future. Okay, see, this is a 16th question. Okay, what is given? A body is there of mass 100 kg, okay, whose initial speed is how much, or initial velocity is how much, 5 meter per second. Okay, and it takes 6 seconds to change its velocity to 8 meter per second. Okay, so initially it was 5 meter per second, then after 6 seconds it becomes 8 meter per second. Okay, and we have to find out its initial momentum. I for initial, P means momentum, P means momentum, F means final momentum we have to find out, and the force exerted on the body we have to find out. Because momentum has changed, that means some force was exerted on the body, only then its momentum can change, no? Okay, so first we have to find out the initial momentum. Now what is initial momentum? Initial momentum is mass into initial velocity. Okay, so we can write mass is how much, 100 kg, initial velocity is how much, 5. So what you will get, 500 kg meter per second. That is our initial momentum. Okay, now we have to find out the final momentum, that is mass into final velocity, and that is mass is again 100 kg, final velocity is 8 meter per second. What we are going to get, 800, that is kg meter per second. Okay, now next what we have to find out, we have to find out the force. Okay, and we know what is force according to Newton's second law. F is equals to mass into acceleration. Mass is known to us, we have to find out acceleration. Okay, so what is acceleration? Acceleration, we know that it is v minus u by t. So what is force? Force is equals to mass into acceleration. Therefore what we can write, mass is how much, 100, acceleration is v minus u by t. Okay, this is our force. Okay, so I hope you have noted this. Let's see, F is equals to, it is 100 is the mass. What is V? V is 8 meter per second. What is U? It is 5. What is time? It is 6. Okay, so what we'll get, let's see, we will get F is equals to 8 minus 5 is how much, 3. Okay, so we can write, first we can cancel this, 2 3 ja and 2 50 ja. Okay, now 8 minus 5 is 3, so we will write 50 into 3 and by 3. This cancels out, it is 50 50. Okay, so what we will get finally, force is equals to 50 Newton. Okay, just note it down, then I will just remove this. All of you have noted? Okay, so let me write here the answer, that is F is equals to how much, F is equals to 5050 Newton. Okay, so done, very nice. Okay, see, in question number 17, no, it is a descriptive type question. Means question is longer but answer is very small. Okay, it is conceptual based. There is Akhtar, Kiran and Rahul. They all are traveling in a car. Okay, a very fast moving car on an expressway. Okay, with a huge velocity. Now what happens, no, as they are moving, suddenly what they find, no, an insect comes and gets stuck with the windshield of the car. Okay, now this Kiran comes with an explanation. Okay, she says, okay, this because insect had a very its change in velocity is large, because see, it was flying in this direction, and now when it's stuck with the windshield, now it is moving with the car, okay, in the forward direction. So there is a huge change in momentum of the insect, okay. So more force was applied on the insect, and its momentum also, change of momentum was also more, okay. Now what Akhtar told that, see, actually car was moving with huge speed, so it applied more force on the insect, okay. And uh, and that's why the insect died, okay. uh, this was the explanation of Akhtar, okay. Now Rahul came with some different explanation. He told that no, the insect and the car both suffered same change in momentum, and both exerted equal force on each other. Now the question is that we have to suggest what is the correct thing, okay. So see, when we are talking about what is correct thing conceptually, here this question is under this, it can be, it can be solved, or we must think on the Newton's third law, okay, for this question. What the third law states: for every action there is equal and opposite reaction, okay. So when both are colliding, that means both are exerting equal force and opposite force, okay. So whatever force the insect is applying on the windshield, the same force windshield of the car is applying on the insect in the opposite direction. So force applied is same, okay. So Akhtar and Kiran is wrong, okay. Now second thing, what about the change of momentum of both of them? We know very well that force is directly proportional to change in momentum by time, okay. So change in momentum, because see, change in momentum is same, okay. Why? Because force is same. What is this time? This time is time which they took, okay, for means to come in contact, okay, to collide. So that is the time. That is very small time, okay. That will be equal for both of them. So that's not a problem. So F is proportional to delta P. That means force is proportional to change in momentum. But force is equal for each other, and therefore we can say that, just write the answer. Write the answer. According to Newton's third law, the force applied by the insect on the windshield of the car and force applied by the windshield of the car on the insect, force applied by windshield of the car on the insect, both are equal and opposite. Full stop. As both are exerting equal force on each other due to collision, comma, so their change in momentum also will be same. Full stop. Hence, statement of Rahul is correct, and the statement of Kiran and Akhtar is not correct. Okay, done. That was your question number 17. See, next, this is question number 18. In question number 18, what is given? There is a dumbbell. I think all of you know dumbbell, okay, which is used in gyms. Dumbbell is there, and which was held 80 centimeter above the ground, okay, and suddenly it falls from the hands of the person who was using it, okay. And see, the moment it starts falling, okay, at that moment, what is the velocity of the dumbbell? Obviously it is at zero velocity, no. The initial velocity is how much? 0 meter per second. Now what they have told, the mass of the dumbbell is 10 kg and the acceleration of the dumbbell is 10 meter per second square while falling downward, okay. When it is falling downward, its acceleration is 10 meter per second square. That is given in the question. Now what they have asked that what is the momentum which this dumbbell is going to impart to the floor? How much momentum it will impart to the floor? That is the question. So we need to find out the final momentum. Okay, we need to find out the final momentum. Now in order to find the final momentum, we have to find out the final velocity. Okay, so we know that final velocity is what? V is equals to u plus at, but time is given or not? It's not given. So can we use V is equals to u plus at? No, not at all. Then what we have to use? Let's see. Can we use V square is equals to u square plus 2as? Obviously, because this height is given, so height is like a s. Okay, so that we can use over here. So V we don't know, we have to find it out. U is 0, so 0 square plus 2. A is how much? 10, and S is how much? 80 into 10 to the power minus 2. Because so it was given in centimeter. Okay, so in order to convert into meter, I have multiplied with 10 to the power minus 2. Okay, you used to divide it by 100 to convert into meter. That divide by 100 can be written as 10 is the multiplied by 10 is the power minus 2. Okay, so that's what I have done over here. Now this 0, okay, is 0 only. Okay, so now 8 to the 16. Okay, and then 2 zeros, 1 6 and 2 zeros into 10 is the power minus 2. Okay, that is V square. Now just see here. Can you write 16 into 10 is the power plus 2? And here it is 10 to the power minus 2. Both will cancel out. We will left with V square is equals to 16. So V is how much? It is square root of 16. Okay, and that what we write? V is equals to 4 meter per second. Okay, that is the final velocity. Yes, obviously it can be positive and negative both. Okay, but let's take positive only. Okay, because negative is only direction will reverse, and we are not talking about direction over here. Count out the velocity. Now it's very easy to find the momentum. Okay, so what is the momentum imparted by it? Okay, so we got the velocity. Now we can move ahead. See, final momentum of the dumbbell was how much? M into final velocity. M is how much? It is 10 kg. Final velocity was how much? 4. So what we get? 40 kg meter per second. That is the final momentum of the dumbbell. As soon as the dumbbell falls on the floor, it comes to rest. That means its momentum becomes 0. Then where that momentum goes? Okay, that momentum is transferred to the floor. Okay, so what I will write? Hence, momentum transferred to the floor. Okay, hence momentum transferred to the floor is 40 kg meter per second. Okay, with this we have completed question number 18. Let's note it down. Done. Okay, see, actually your main exercise is over, but there is some additional exercises given in your, okay, additional exercise is given in your book. Okay, you can see this is the additional exercise. In this additional exercise, the first question is that, question number 1 in the additional exercise is that, see, this chart is given. Actually a vehicle is moving, a body is moving. Okay, at 0 second, see, time is taken in seconds, distance is taken in meters. Okay, at 0 second it is at 0 position. Okay, it has covered 0 meter. In first 1 second it has covered 1 meter. Okay, in 2 seconds it has covered 8 meter. In 3 seconds it has covered 27 meter. In 4 it is 64. In 5 seconds 125. 6 seconds 216, and 7 seconds 343 meter it has covered. Okay, now we have first what we have to find out. By seeing this data, we have to find out that is the acceleration of the body is constant or increasing or decreasing. Okay, that's what we have to find out. Now see, what is the initial velocity of the body? Initially it is at rest, because see, at 0 time it is convert 0 meter. Okay, 0 meter.
So what you can say, see, we know this formula, S is equals to ut plus half at square. Okay, and initial velocity is 0. As initial velocity is 0, what we can write from here? S is equals to at square by 2. Okay, rather by 2. From here, can we get the value of A? A is equals to what? It is 2s by t square. Okay, just keep on putting the value of distance and time, you will get the corresponding acceleration. So we can do one thing, we can draw a line over here and we can get the acceleration in meter per second square. Okay, it is meter per second square. We can get the acceleration. Now s is equals to 0, t is also 0. 0 by 0 is how much? 0. Now 2 into 1, because distance is 1 inside. So 2 into 1 is 2, and here 1 square is 1. Okay, so 2 by 1 is how much? 2 meter per second square. Here what I will write? Okay. Okay, now in third case, see, s is how much? S is 8. So 8 to the 16. And t is how much? 2. So 2 square is 4. Okay, so 16 by 4 is how much? 4. Okay, so acceleration is 4. Now for third one, fourth one. Okay, fourth one, see, s is how much? 27. 27 to the 54. And 3 square is how much? 9. Okay, so you have to divide 54 by 9. Okay, six ja. Okay, rather I should write it here a little bit up. Okay, in this line. Now s is 64. So 64 to the is how much? 128. And t is 4. 4 square is 16. You have to divide 128 by 16. Okay, so we can write 64 by how much? 8. So 8 will get. In the same way for this, it is 150. 125 to the 150, and then 5 square is 25. So 150 by 25. Okay, it is 5 square. Yes, 125 to the 250. Sorry, 250. 125 to the 250, and this is how much? 5 square. So 250 by 25. 250 by 25 means, see, 25 4 is 100, 25 8 is 200. Okay, 25 10 is 250. So we will get here 10. In this case, s is 216, so double of that, that is 432. Okay, 432, and time is 6, so 6 square. 6 square is how much? 36. Okay, 432 by 36. What we are going to get? It is 12. Okay, we will divide it, you will get 12. We can check it by dividing. And the last one, s is how much? 343. 343 into 2. So we will get 686. And 7 square is 49. 686 by 49, what we are going to get? We are going to get 14. Okay, so we got the acceleration. Now by seeing this, what you can say? Acceleration is constant. It is increasing or decreasing? Just check it. 0 to 0 meter per second square, 2 meter per second square, then 4 meter per second square, then 6, then 8, then 10, then 12, then 14. So we can say that acceleration is increasing. Okay, so you can write the answer of part A. Okay, acceleration is increasing. Okay, now what about part B? They have asked that what about the force? Obviously, when acceleration is increasing, then external unbalanced force acting on the body is also increasing. Okay, so external unbalanced force acting on the body is also increasing. Okay, because when acceleration is increasing, then force will also increase, because you know force is equals to what? Force is equals to mass into acceleration, and this is increasing and this is constant. Okay, so when acceleration is increasing, force will also increase because mass is constant. Okay, clear? So note it down. Noted. Okay. See, in this question number 2 of additional exercise, what is given? A car is there. Okay, motor car is there, and that car is being pushed by two persons. Okay, when it is being pushed by two persons, then car is just moving with uniform velocity. Okay, now see, when we are pushing a body, when force is applied on a body and body is just moving with uniform velocity, what does it means? See, suppose this is the road and you've got your car over here. Okay, this is your luxurious car. Okay, and two persons are pushing here. Okay, two persons are there. Okay, and one person is here. These two persons are pushing this car, and then it is moving with uniform velocity. Now, with uniform velocity means v is constant. Okay, now see, what does it means? That means whatever force they are applying, suppose they are applying F, one person is applying force F, small f, so he is also applying force small f. Okay, and some friction force is also acting. Okay, let it be capital F. Okay, so that means capital F is balanced by this 2f, that is force applied by these two people. Okay, and that's why this body is not accelerating, because see, if these two are equal, then what is the net force on the car? Net force will be, that is 2f minus f, because this is opposing force, so that's why we will take negative. So this is the net force, and net force is how much? 0. So there is no acceleration. If there is no acceleration, then body will move with constant velocity. Okay, now their question is that after this what happens? A third person comes. Okay, and he also starts applying force on this, the same force. Okay, it has been assumed that all the persons are applying same muscular force. Okay, so apply same force on this, and then the body gets an acceleration of 0.2 meter per second square. Now the question is that how much force each person is applying on the motor car. Okay, now see, till two persons there was no acceleration, so whatever acceleration has occurred, that is due to the third person only. Okay, so how much force the third person has applied, that we can find out. Okay, very easily. I'm going to remove this diagram. I think you have understood. I'm going to remove this diagram. So the whole acceleration was caused due to the force of third person. So force of third person was F, and F is equals to M into A. So M is how much? It is 1200. Okay, A is how much? 0.2. So what we can get, see, 12 to the 24, 24 and 2 zeros. Okay, but decimal is after one place, so you will get what? 240 Newton. So that means the third person applied this much force. Okay, now as all the persons were applying equal force, okay, that was there in the question. So after this you can write no. Therefore, force applied by each person is 240 Newton. Okay, force applied by each person is how much? 240 Newton. Now that was asked in the question. We can ask one more question in that. Okay, if you want, what is the frictional force acting on the wheels of the motor car? That you can add in this. Okay, so can you find out the frictional force? Obviously frictional force was how much? It was 2f. Okay, so you can get the frictional force also if you want. 2 into 240 Newton. So what you will get? 480 Newton. That was the frictional force acting on the wheels of the car, okay, which was applied by the road. Clear? Frictional force, you know, it is opposing force. Clear? Okay. See, in this third question of additional exercise, what is there? Actually, there is a nail, okay? Nail, you know very well. Its nail is like somewhat like this. Okay? There is a nail. And there is a hammer. Okay? Mass of the hammer is how much? It is 500 gram. Okay? We can convert into kg. We have to multiply how much? 10 raised to the power minus 3. So we can get into kg. Okay? Now its velocity is how much? Its velocity is 50 meter per second. Okay? When it hits the nail, okay, then obviously it comes to rest. So what is its final velocity? Final velocity is 0 meter per second. Okay? Now, the question is that when it is hitting the nail, how much force the nail is applying on the hammer? We know that there is no external forces acting. When hammer is hitting the nail is also hitting the hammer. So we can say it is Newton's third law. Both are applying equal and opposite force. So we can find out the force of hammer, and that will be equal to the force applied by the nail on the hammer. Okay, force applied by hammer on the nail is equal to the force applied by the nail on the hammer. Okay, only the directions are opposite according to Newton's third law. Okay, so how to find the force? We know that force is equal to mass into acceleration, but also we know mass into acceleration means v minus u by t. Okay, so we can use this formula now. Now see, F is equals to m is how much? It is 500 into 10 raised to the power minus 3. V is how much? It is 0. U is how much? It is 50. And T is how much? It is 0.01 second. Okay. Now what you will get? See here. We will get here F is equals to, this is 500. Okay. Can we write it 5 into 10 raised to the power 2? And this is 10 raised to the power minus 3. Okay. 0 minus 50 is minus 50 only. Okay. Okay. So minus 50, and this two places are there. So we can remove this decimal and we can add 2 zeros. So what we will get? 5000 by 1. So we can write here minus 5000. Okay. By 1. Why we did not write 1? Okay. We don't write 1 actually. So we are getting this. Now from here what we can write? Just check it. I put up this diagram and some more lines I put up. See here what we are getting. F is equals to this plus 2 minus 3 is minus 1. So we can write 5, and rather we can write this minus first. Minus into plus is minus. Minus 5 into 5 is 25. 1000 was there. 1, 2, 3. 1000 was there. Okay. And then we are left with 10 raised to the power minus 1. Okay. Because plus 2 minus 3 is how much? Minus 1. So minus 1 is left. Now, due to this minus 1, what we can write? We can put the decimal over here. So we get minus 2500.0 Newton. Okay. Or we can write minus 2500 Newton. That is the force applied by whom? By hammer on the nail. But what about the force applied by nail on the hammer? We know that forces are equal and opposite. Okay. So force applied by nail on hammer is F is equals to 2500 Newton. Why minus sign is not there? Because its direction is opposite. When direction is opposite, then you have to put minus sign, and minus was already there. So minus minus plus. Okay. So The force applied by nail on hammer is 2500 Newton. Clear? Note it down. See, this is the fourth question of additional exercise. Okay. Now, and it is the last question of this chapter. Okay. Also, see what is given. A car is given. Okay, whose mass is how much? 1200 kg. Okay, and initially it is moving with velocity of 90 km per hour. Okay, and then what happens? Its velocity decreases. Okay, to 18 km per hour. In how much time? In 4 seconds. So this was velocity, and after 4 seconds, what velocity has decreased to 18 km per hour. Okay. Now the question is that what is acceleration, what is change in momentum, and what is force acting on it? Because some force is acting, that's why the velocity has gone down. No. Okay. So first of all, we have to convert this velocity into meter per second. That is SI unit. Okay. So we know that if it is written 90 km per hour. What we can write? We can write 90 into 5 by 18. Okay, meter per second. Now, 18 5 ja 90. So 5 5 ja 25. So how much will get? 25 meter per second. Okay. So here we can write it as 25 meter per second. Okay. Now, what is about the final velocity? That is 18 km per hour. We have to convert into meter per second. So 18 into again 5 by 18 meter per second. We can cancel this. 1 into 5 is 5. So we get how much? 5 meter per second. So final velocity is how much? It is 5 meter per second. Okay. So we got both the velocities in meter per second. Now, can we find out the change in momentum? We can find out acceleration. Let's see. So I write this. Okay. Acceleration is v minus u by t. Okay. So v is how much? It is 5. U is 25. Time is 4 seconds. So if when you subtract 25 out of 5, that means what you will get? Obviously you will get minus 20 by 4. And what you will get? 4 5 ja 20. So minus 5 meter per second square. Okay, that's what is your acceleration. So first part you have done, you have got the acceleration. It is minus 5 meter per second square. Okay, now we have to find out the change in momentum. Okay, so for change in momentum, what do you know? Should I rub this? Okay. Change in momentum means what? Final momentum minus initial momentum. Final momentum is how much? Final momentum is m into v. Initial momentum is m into u. Okay. So m is how much? M is 1200. V is how much? It is 5 minus, it is again 1200. U is how much? It is 25. Okay. So what we can do? Can we take 1200 common? 1200. We will have 5 minus 25. What will get from here? Minus 20. Minus 20 into this much. So minus will come on the front. Okay. Rather, I take one more step so that it becomes easy for you to understand. Now we can write this minus here because minus into plus is minus. 12 to the 24. 2 zeros here, 1 0 here. So 1 2 3 0. Okay, that is there. So minus 2 4 000. Okay, that is kg meter per second. That is change in momentum. Okay, so we got the change in momentum also. Now we have to find out the force acting. Okay, so for force, let's see. Should I rub this? You've done. Okay. So in order to find out the force acting, what we can say, F is equals to m into a. What is mass? It is 1200. Acceleration is minus 5 meter per second square. Already we have calculated in first part. Okay. We can multiply this. 12 5 is 16. Minus is also there. And this double 0. Okay. this much Newton force is acting. Minus sign indicates that this force is acting in the direction opposite to the motion of the body. Okay, and that's why body slows down. Clear? Now this question. Now see, with this we have finished the chapter, that is force and laws of motion. Okay. If you got any queries, any doubt, okay, you can just write in my comments, okay, or you can just ask me, okay. With this, we finish this chapter. Take care of yourself. Keep on studying, okay. And in the next video, I will come with the next chapter of class 9th, that is gravitation, okay. So we'll start the gravitation. I think you've studied some small part of that in class 8th, okay. So it will be helpful to us, okay. Till then, thank you. Bye bye.